Greetings, this is Chemistry with Nav. In this video today we're going to take a look at the free radical substitution of alkanes. And in that process you take an alkane and you react it with a halogen, and it creates a halogenoalkane and a hydrogen halide. There is a necessary condition for this, which is that it must be done with UV light. And the type of bond fission that's going on is homolytic fission. And homolytic fission can be seen in the first step of this process. It literally means same splitting. And what's going on is that the UV light here is actually causing the covalent bond between the two chlorine atoms to break evenly, hence the same splitting. And in doing so it creates two chlorine radicals. As we move on to the propagation steps, we take that chlorine radical and we put it in with a methane molecule, and what happens now is the same homolytic fission, except the bond between the carbon and hydrogen puts one electron onto the hydrogen, which is then matched by one electron from the chlorine radical. In the process of doing that, we end up making a methyl radical, and we make hydrogen chloride, which is the byproduct in this reaction. The second propagation step takes the methyl radical from before, that puts its electron in, the chlorine then breaks also by homolytic fission, and we end up making our product, which is chloromethane, CH3Cl, and the chlorine radical. In the termination step, we can take any two radicals that we choose and stick them together. That's because when you put those two radicals together, they will form a covalent bond, and that creates either the chloromethane, CH3Cl, if we have a methyl radical meeting a chlorine radical, or if we have two methyl radicals, we might actually make ethane. And the production of ethane is quite an important step in this mechanism, because it's one of those things where we've put methane in, we've got ethane out, and this free radical mechanism is one of the reasons we can explain why we might get ethane out here.